Welcome back. Today we're doing a deep dive into a really critical forecast. We're looking at Europe, Western Russia, and the North Caucasus for the end of August 2025, specifically the 21st to the 30th. Our goal here is to unpack what meteorologists are calling a period of acute and multifaceted risk, basically how a severe heat wave and intense thunderstorms are linked.
Exactly. And that's really crucial for you to grasp. This isn't just about predicting the weather for a few days. It's a real manifestation of Europe's emerging climate reality. It shows how these threats connect and amplify each other.
Okay, let's start with the main driver then. This persistent heat dome. It's described as a powerful, stationary, high-pressure ridge. How exactly does that create such extreme heat?
Right, so think of it like a giant lid placed over the atmosphere. Air underneath it is forced to sink. And as it sinks, it compresses and warms up quite dramatically. That's the adiabatic process. Combine that with generally clear skies under high pressure, meaning maximum sunshine reaching the ground, and if the soil is dry already.
Which it likely is by late August in many areas.
Precisely. Less moisture means less evaporative cooling, so more energy goes directly into heating the air.
Yeah.
It becomes a self-reinforcing cycle. The heat just builds and builds.
And where is this hitting hardest? The forecast highlights the Iberian Peninsula, France, Italy, the Benelux nations, Germany, even the southern UK. We're talking temperatures consistently over 35, even 40 degrees Celsius. Some spots in France might see, 43 degrees?
Yes, potentially. And remember, these are anomalies of +6 to +10 degrees Celsius above the late August average. That's huge.
Huge. And the impacts go way beyond just feeling hot, I imagine.
Oh, absolutely. It's a major public health emergency waiting to happen, especially for vulnerable people. And think about Europe. Air conditioning isn't nearly as widespread as, say, in the U.S., maybe only 20% penetration overall.
Right.
Plus, you get these tropical nights where the temperature doesn't drop below 20 Celsius. Your body just gets no chance to recover. Then there's the strain on power grids, worsening drought conditions for agriculture, and, of course, a very high risk of wildfires on that parched land.
Okay, so intense heat under the dome, but that's not the whole picture, is it? Let's unpack the other side of this ring of fire of severe storms around the edges.
Exactly. While you have this stable hot air dome, you get a really sharp contrast with cooler, more unsettled air to the north and east. This boundary, this temperature gradient, is what we call a baroclinic zone, and it's like fuel for storms. You get tremendous atmospheric energy K, or convective available potential energy building up. It's like a loaded gun just waiting for a trigger to cause explosive updrafts.
And the main corridors for these storms looks like from the Alps across Central and Eastern Europe, then into Western Russia and the North Caucasus.
That's the track, yeah.
What kind of threats are we actually talking about with these storms?
Several severe ones. Destructive hail, potentially very large diameter hail. Torrential rainfall, which is especially dangerous because it falls on ground that's often baked hard by the heat, so it can't soak in quickly. That means flash floods.
Right, runoff increases dramatically.
Exactly. And also damaging straight-line winds coming out of these powerful storm cells.
Okay, now here's something I find really interesting. You mentioned large hail, but isn't a warmer atmosphere supposed to, melt hail more easily? It seems a bit counterintuitive.
It does seem that way, doesn't it? And for smaller hail, that's generally true. A higher melting level means more melting on the way down. But the key here is the strength of the updrafts. With more energy, higher steep E, these storms have much stronger updrafts. They can keep hailstones suspended for longer, allowing them to grow much, much larger before they eventually fall. So even with a higher melting level, these now giant hailstones are more likely to survive the journey to the ground. We're already seeing this trend in places like northern Italy, southern France, the Caucasus.
Fascinating. So bringing this all together, what does the specific forecast, this pattern, tell us about the bigger climate picture?
Well, it tells us these aren't just random freak events. They are fundamentally amplified by human-caused climate change. We have to remember, Europe is warming incredibly fast, more than double the global average rate since the 1980s. That underlying warming makes these extreme patterns, like persistent heat domes and the intense storms they fuel, more probable and definitely more severe. This forecast period isn't just weather, it's really a climate event. It's showing you very directly the interconnected and compounding impacts of that long-term warming trend.
So, summing up then, this late August period looks like a stark preview, a case study maybe of Europe's emerging climate reality. It's defined by these linked threats, extreme heat, and violent storms.
Precisely. And it really underscores the need for a proactive response, not just dealing with heat or floods or hail separately. We need a multi-hazard approach and a much faster acceleration of climate adaptation measures across the continent because it's kind of pattern. It's likely indicative of what future European summers will increasingly look like. We need to move beyond siloed risk management to something much more systemic.
A critical message. Lots for you, our listeners, to think about there regarding these complexities and their wider significance. Thanks for joining us on the Deep Dive.